this is WebAssign 9A, number 10, problem number 10. So it reads, a proton is projected in the positive x direction into a region of uniform electric field of negative 6.80 times 10 to the fifth newtons per coulombs at t equals 0. The proton travels 7.90 centimeters as it comes to rest. Part A asks to determine the acceleration of the proton. So we know that the force is equal to QE, the electric force, so this is part A. And we know that F is just equal to MA, so we can just set QE and MA equal to each other. Q being the charge of a proton and E being the electric field. And this is where some kids might get stumped up because they don't know how to find the charge, and they don't know that you can just look up the charge of a proton, or you can look in a packet or something. If they give it to you on a test or something, they'll probably tell you. But yeah, so Q is charge of the proton, which comes out to be, if we rearrange all this, solving for A, we get that Q 1.602 times 10 to the negative 19th multiplied by E, negative 6.8 times 10 to the fifth newtons per coulomb. This is coulombs. All over the mass, which was 1.67 times 10 to the negative 27. That's also where kids get stumped up too, because a proton, you can just look up the mass of a proton, or you can look up the mass charge of a proton or electron. You can just look that stuff up, or it'll be in your packet or something, or you can just memorize it. But that'll be a good thing to do, is memorize the charges and masses of protons and electrons. So, and this comes out to be, the acceleration is negative 0.652, negative 6.52 times 10 to the 13th. And this actually makes sense because as it comes to rest, so you know it's slowing down, so it has to be negative. The acceleration should be negative. And then part B asks to determine the initial speed of the proton. So we can just use kinematics. We know we have the acceleration, we have its displacement, and we know its final velocity, which is 0, so we can use the kinematic v squared is equal to v initial squared plus 2a delta x, solving for v naught. So we know v final is 0 because it tells us that it comes to rest. We're solving for v naught plus 2 times the acceleration, which we just found. So we do negative 6.52 times 10 to the 13th, and then times displacement. And don't forget to convert that. Don't forget to convert, it gives it to you in centimeters and you need it in meters, so just move the decimal point. Meters. Sorry. Don't forget your units too. Meters per second squared. Meters per second squared, this one. Okay, and then the final velocity, the initial velocity comes out to be 3209610.6. Big number, but because the acceleration is also a pretty big number. Well, it's a negative, so it's slowing down really fast. So part C, it says determine the time interval over which the proton comes to rest. So we know final velocity, we know acceleration, we know its initial velocity. Now we know delta x, so we can just use the kinematic. Delta x is equal to v final plus v initial over 2 times time. We just solve for t. So plugging in for everything, we get 0.079 meters is equal to 3209610.6 meters per second over 2, and then that's plus 0 because final velocity was 0. Final velocity 0 comes to rest. And we solve for time. Up here, sorry, forgot the units up here, meters per second. And then we get that the final answer is 4.9 times 10 to the negative 8th. So this is a fairly simple problem. Nothing really too hard. Just remember that if it gives you, this is pretty basic. Like, it was new. Just introduce you to electric fields and using protons, I guess, like, and charge and electric fields together. And also, like, I learned about how to use you can kind of relate like normal, like when you use like regular forces with like the electric force, so you can kind of combine those equations, that MA equals to QE. That's just like basic stuff though. But yeah, pretty straightforward problem here.